Let's take a look at one more example of projectile motion in the sixth motion video. This problem is a little bit more difficult because the projectile is originally launched at an angle. Find the horizontal range if the projectile is launched at 62 degrees at a velocity of 25.5 meters per second. First, we will record the information we are given. We know the initial velocity is 25.5 meters per second. We will have to break this into its x and y components. We also know the angle the projectile is launched at is 62 degrees. We need to find the horizontal distance s sub x. The basic equations that we will use to break up the velocity into its x and y components are the magnitude of the velocity in the x direction is equal to the magnitude of the velocity times cosine of alpha, the launch angle. The magnitude of the velocity in the y direction is equal to the magnitude of the velocity times the sine of alpha. The horizontal distance, s sub x, is equal to the x component of velocity multiplied by time, and the time is equal to the final velocity in y minus the initial velocity in y divided by the acceleration. Next, we can substitute to find the x and the y components of velocity. The magnitude of the x component of velocity is 25.5 meters per second times the cosine of 62 degrees. This means the x component of velocity is 12.0 meters per second when rounded to 3 significant digits. It is positive because we are assuming positive is to the right. Next, we can substitute to find the y component of velocity, which is 25.5 meters per second times the sine of 62 degrees. This gives us a y component of velocity to be at 22.5 meters per second. This one is negative because the projectile is being launched up, and we defined up to be negative. Now that we have the x and the y components of velocity, we can substitute into the second set of equations to find the time and distance in x. First, time is equal to the final velocity in y minus the initial velocity in y divided by the acceleration due to gravity. Anytime we are working with projectiles and we are initially shooting an object up, the initial and final velocity of the y component will be the same, since the only thing affecting the y component of velocity is the acceleration due to gravity. This means that the final and initial velocity in y is 22.5 meters per second. The only difference is that one of these velocities will be positive and the other will be negative. We will define up as negative and down as positive, like the previous slide. This means our initial velocity in y is negative and the final velocity in y is positive. 22.5 meters per second minus negative 22.5 meters per second divided by 9.80 meters per second squared gives us a time of 4.59 seconds. Now that we know how long the projectile is in the air, we can solve for the distance traveled in x. The distance in x is equal to the velocity in x multiplied by time. Substituting, we have 12.5 meters per second times 4.59 seconds gives us a distance of 57.4 meters. This concludes our example of projectile motion and of the motion unit.